we're thinking about the region beyond the termination shock. And the termination shock is a region where the supersonic solar wind goes through a shock. So you can think about a big waterfall that the solar wind goes and starts slowing down as it's approaching the interstellar medium. Now, the heliopause is what separates us from the rest of the galaxy, the interstellar medium. So the sun, with its wind, it's carved like a bubble in the interstellar medium, and the wind coming from the sun clashes against the interstellar medium and forms this boundary that we call heliopause. So the missions that we are learning about this very interesting region are coming from two different spacecrafts. One is a Voyager spacecraft that were launched in 1977. So it took them 30 years to arrive there. And you have also the IBEX mission that was just launched in 2008, October, and got the first maps of the energetic neutrals. So we're learning from these two different missions. Voyager is measuring in situ, so it's right there measuring, and the IBEX is looking at a global view or about the same region. Our heliosphere is asymmetric, is not identical in the northern hemisphere and the southern hemisphere, or in the east and west. The reason for that is the interstellar magnetic field that is pushing and shaping how we look from outside. So the new knowledge that we are gathering from this new data, these new observations, are going to help us understand the whole heliosphere and also some processes even close to the sun. For example, what I mentioned earlier about acceleration of particles. The fact that particles maybe is not as simple as going through a shock and accelerating particles. Maybe they're accelerated in the sides of shocks, or maybe in sheath, in coronal mass ejections. This knowledge that we are gathering at the edge of the solar system probably will influence not just the edge, but also other ionized matter. One of them are cosmic rays come from outside the heliosphere and make their way, and they're very energetic and they're hazardous for astronauts. If you're sitting on Earth, we have the Earth's magnetic field to shield us from energetic particles, and they're deflected around. As soon as we leave Earth, send astronauts to Moon, to Mars, to beyond, they are not protected. We have to have an idea how large and how intense those cosmic rays are going to be, and when and how they're going to affect the astronauts, for example. We expect phenomena like reconnection to happen. And reconnection is where the solar magnetic, in any magnetic field with opposite direction, annihilate and can release energy and accelerate particles. And we expect the solar wind, the magnetic field from the sun, to encounter the magnetic field coming outside from the interstellar medium and annihilate in certain points of the heliopause.